Okay, good morning, everybody. Do you really need Hibernate? Having this talk already at the conference last year, and after my talk, someone came to me and said, "Hey, Simon, do you know about Betteridge's Law?" And I said, no idea. And he explained that Betteridge's Law is the law about headlines. And if the title or the headline is a question, the answer is always no. But we are all software developers, so the answer is always, it depends. So I will talk about if you really need Hibernate and show you an alternative to build data-centric applications. I'm Simon. I'm from Switzerland, and I have my own company there, and I'm very active in the Java space, so I'm the Java user group leader in Bern. I'm also a member of the Java community process, and I'm teaching at 2 universities in Switzerland. And I'm teaching Hibernate for about 17 years. So I think I know it quite well, and I also know the problem about that. But before we dig into technology, I like to talk to you about what I do in my spare time. So I'm in a sports club in Switzerland. I used to do track and field years ago, and I still do that. And what we have there is a competition 3 times a year for kids. So they do running, long jump, and so on. And when I joined the sports club later, when I was a software engineer, I realized that they do everything on forms, and they had these tables to calculate the points by the results. And I said, hey, that's not possible. I'm a software engineer. I have to find a solution for that. And so what did I do? I created a project called JTAF, for Java Track and Field. And it's open source. It's freely available. It's even software as a service. You can use that if you're doing track and field events. And the application is very simple. So that's kind of a dashboard. And what you can do here, for example, you can create a ranking list. So a ranking list is a tree. So we have the competition, we have the categories, it's all in German. I'm sorry about that. But we have also the participants, and here below, for example, we have 80 meters run. It took him 11 seconds and 75. That gives him 459 points. So, and here are the total points, and we create this ranking list. And I want to talk to you about this ranking list because this is very special because it's a tree. And we all know if you access the database, the result is always a table. So you can't use a table for creating a tree, but we can do that, and that's what I will talk to you as well. The other thing that I want to show you is the rest of the application. So there is very little business logic. The only business logic, in fact, that really exists is if we are looking for an athlete, and here we can, for example, change the result. Then you see that in this field here, it's immediately calculating the points. And that's the only business logic, or the only thing that I would call that's business logic. All the rest is just CRUD. So create, read, update, and delete. For example, I can here change the name of Stella to Lisa, for example, and save it. So you know about these types of applications. I call that data-centric business applications. Who of you is working on such kind of applications? So some of you. And for that, it really depends how you build your application. And there also depends how you want to build the data access layer. So just to give you an idea, if we go to the demo later on about the data model, so we have on top, it's called an organization. That means the application is multi-tenant capable. So you can have, like, if you maybe watch TV and see track and field events, there is the Diamond League. Formerly it was known as the Golden League. That's a big competition around the world with multiple locations. They do kind of multiple sports events. And there they have a series. That means you have multiple competitions, and if you participate in any competition, you will be part of the series ranking list, and then you will be awarded. That's why it's called Golden League or Diamond League. So we do similar stuff, And then we have the rest. So we have like an athlete. It's maybe part of a club. It's in a category. It has an event like 80 meters or long jump, high jump, etc. And then we get the results. So it's very simple data model. By the way, the first version for this application I created in 1997 with Access back in the days, because I didn't knew about Java back then. And this was already more or less the same data model back then. So also the business logic didn't change, because the formula to calculate the points is from the International Athletics Federation, and we have to adjust it because we do the competition with kids, and the formulas are made for adults, so we have to change that a bit. So that's the data model of the application. But maybe first we have a look about JPA versus Juke. The point is, if you're using JPA with Hibernate or Eclipse Link or whatever, it doesn't really matter, or any other wire mapping framework, also in other languages, you have an approach that I call entity state transition. What does that mean? You load data from the database, and then you have an object model. You have relationships between the objects that you load, and then you start changing the state of your entity. It doesn't matter if it's just an entity with some getters and setters, or if it's a real entity with some business logic on it. At the end of the day, when you're finished with your transaction, you have changed the state, and Hibernate will automatically generate, update, insert, delete statements based on the changes you did. So that's what I call entity state transition. And on the other hand, we have another way to do that. It's called data set transformation. Data set transformation means you're interacting directly with the database. So you read data from the database, or you write data to the database. So you don't change like the state of an object, you directly update that, or insert, or delete. And that's usually not the same approach. And as I said, initially, there is no best approach. We learned from Neil Ford, there is no best practices. So there's also not a best approach how to treat your database. It really depends on what type of applications you have. And in my case, with this data-centric business application with very little business logic, I would say the entity state transition is not the best way to do that, because usually you have to first load the data before you can change it, for example. So, but you can also use like bulk update statements in Hibernate. That's not the point, but maybe there's another approach that we can follow. And the tool that I like to show you is called Juke, or JOQ. It's made by Lukas Eder. He's also based in Switzerland, and he was working for a large bank in Switzerland with a huge data model. And they were thinking about how can they access the data model. They also had a lot of stored procedures, because most of the old databases also have logic in the database, not only data. And so he created kind of a type-safe way to access the database. Who of you is doing C# development, maybe? No one. C# knows a concept called LINQ, Language Integrated Query, and they had some additions in the C# language that you can more or less directly write SQL statements in your code. Is someone even old enough to know COBOL? Because I come from IBM mainframe computers back in the days with COBOL. Do we have all COBOL programmers here? No one? There we had something called embedded SQL. So you wrote your SQL statement directly in the COBOL code, and you had a precompiler that was taking this SQL code and created some, for Java we would say it creates JDBC code to execute. That also existed in Java. It was called SQL J. It was around late 90s probably when Oracle created that. No, IBM created it first and Oracle followed, but it didn't took off. So it's dead for already a long while. And that's why Lukas created Juke. So to start with that, I created a project on GitHub. CMAS CH is my GitHub account, and you will find that Juke examples. There is a documentation, the official one, juke.org, and Juke also has a demo project where you can find various ways to use Juke and with various databases. And the point about Juke, in contrast to Hibernate, is Juke is database first. That means you first create the database. So you don't go ahead and create some object or class model and then let, for example, Hibernate generate your database. That's probably something you shouldn't even do because we will not get an optimal database model using that approach. But here Juke really assumes that the database is there. So Juke doesn't create anything in the database. You have to do that by your own. And on the other hand, you can use Juke with any database. So it doesn't matter how the database model looks like. Juke can use everything. And also Juke is database agnostic. That means, like Hibernate, you can change the database if you need to. Who of you already changed the database model or type? One? Only one? Two? Yeah. Usually that's not something you do really often because it involves a lot of work. Especially if you have logic in the database, then it's maybe a bit harder to do that. So Juke, when we look at it, has two parts. So first of all, you have Juke TSL. We will see that in a minute. It looks like SQL in Java. So it's an API that you can use to build your SQL statements. And on the lower part, we have the Juke generator. That's similar to what you have with Hibernate or with API, the meta model API generator that will generate like kind of Java classes out of the database objects that you can use then to run your queries or do whatever. Juke is superior in one point because if you really have functions or stored procedures in the database, Juke generates a class for each function or procedure, and it feels like using regular Java code. So it's not like using this callable statement stuff with JDBC or the complicated way with Hibernate to execute stored procedures. It simply is as you would call some Java objects. Now when I gave this talk, because I'm speaking about my pet project, so it's a very small database model and people said, hey, but does Juke scale? So can I use it for a real database model? And yes, you can. So initially Juke was created for a bank, as I said, and in my current project where I'm working is an ERP product. I'm working there where we do a transformation of Oracle Forms to some other web technology to get a modern interface, but we keep the database model as it is and also the logic in the database, and we have 2,000 tables and around 5,000 stored procedures and functions. So that's absolutely no problem. The only thing that I can say about the generator is this will take a while. So not extracting the information from the data dictionary of the database takes long, but compiling, in that case, around 10,000 classes, this takes a while. So you will see in my example that you can directly generate this meta model on every build, for example. But if you have a huge database, you probably do that better in a separate project and integrate then the generated code as a library. So that's often what you want to do. So that's all that I want to talk about. So let's go ahead and see some code. The Juke example project here is a Spring Boot project, as you can see with the Spring Boot starter here. Juke is you're totally free what framework you want to use. You don't even have to use a framework because Juke just requires a database connection. That's it. So you don't have to use Spring Boot or Quarkus or whatever, but for both popular frameworks, there are starters. So there's a Juke starter for Spring Boot, as you can see here. Also, Quarkus has an extension for Juke that is maintained by Quarkus. And what's happened then is that Juke can take part of the transaction management of your framework that you use. So in case of Spring Boot, you can use transactional annotation, for example, and this works. But Juke also supports transactions out of the box, so you can get a transaction from Juke, and Juke can do something that you are not able to do with standard transaction management in Java. It can do really nested transactions. So nested transactions, some of you do stored procedures programming. They do often nested transactions with save points and you roll back to a certain step. This is not possible with standard Java, but Juke can do that. So you can integrate nested transactions. So if you go down here, I use Java 21. That's now nothing special. I use Flyway here. You can use Lickybase as well to do the migrations. That means here we have the whole database model as a SQL statement with sequences and tables and so on. And finally, I use test containers to test the application. And because this combination of Juke with test containers and Flyway or Lickybase was so popular, test containers created even a plugin to generate the data model. And that's what you can see down here. So there is a test containers Juke, Kochen, Maven plugin. It's a very long name. And what I do here, I specify that I want to use Postgres in my case. And finally, I can configure the container image. I can define the location of my migration script. This is even not necessary. It's just for the demo because this plugin already knows the default location of Lickybase scripts or Flyway scripts. And finally, we have the interesting part. So that's the Juke generator configuration where we define what's the input. We can exclude tables or include tables. You can do that with regex style. And here I just exclude the Flyway schema history table because I don't need that to generate it. And finally, I also can define that the code should be in this package that I defined there. There is a lot more about the generator. You can generate database access objects, so kind of repository layer directly if you want to use that. Or you can also generate pochos and stuff. But let's see what Juke is generating. Juke is generating the code into generated sources Juke. That's also the default location of an annotation processor. And here we have the objects that are generated. So we have some general information about the database schema. So we have like constants for each table. And this is very similar to the Hibernate Meta Model API. So the Hibernate Meta Model API, you would have like classes for each entity you have that you can use to build type-safe queries. Here we have types or constants for each object in the database. So we have for each table. And then it generates also classes for the tables with all the fields. And it extracts everything that it can find in the database. Means it has a name, it has a type. We know if it's nullable or not. We know if it's an identity field. And here I was lazy, so there's no comment in the database. But if you comment the database tables or the columns, then this will also be extracted by Juke. And so the Java developer can see the documentation that the database administrator or the developer that created the database table is using. So that's a very good thing. We also see that we can see the size of the different fields or the columns in the database. And this is not only handy to create the type-safe C code, but this is also very handy if you want to get information about the database. So for example, in the ERP system, we have some of the forms that are auto-generated based on the database model generated by Juke, because we all know the information. We know if we have to have a text field or a number field or a text area, depending on how big the field is. So that's one thing, and we will see that in action in a minute. And on the other hand, we have something called records. So as we don't model an entity model, on the Java side, we also don't have any relationships. right? So we have the plain records that represents a record in the database. And if you have a look at that, the record implements a class or extends a class called updatable record. And updatable record is like an implementation of the data access object pattern and or the active record pattern. That means updatable record has methods like store or delete. So we can use these records to fetch from the database, then you can change it and store it back to the database. So that's kind of a minimal object relational mapping functionality, but without the relationships. Right? So that means the athlete, for example, has a reference to a club, but here we just find the club ID. So there's no real reference to the club. So that's what's getting generated, and then let's have a look at the test. We have here create test. And here we see the integration with Spring Boot, because first of all, we define the class transactional. That means every test method will be rollbacked, so we don't change any data during our tests. But we also have a test slice. So do you know, everybody knows what test slices are in Spring Boot? Just to recap, test slices are a way to reduce the application context that Spring Boot is creating. So if you start a Spring Boot test, for example, the whole application context will be created with everything. Expect the Tomcat if you have a web layer, because this is not included, but it creates too much. Because here we just want to test the database layer, right? So we want to test the lowest layer, so that's also why we have a JPA test, for example, and we have a Juke test, which only creates the Juke stuff that's necessary, plus the database connection tool and the data source. So that's all that's created here. So this improves the startup time of our tests. Then we inject the DSL context. So the DSL context is the main interface you use together with Juke. So it's similar or comparable to like the entity manager or the session in Hibernate. And this you will use to write your SQL statement. And here I've created a simple one, the first one. And here you see that we can use the DSL. Here we have a shortcut to do a select star from something. It's just select from. And here I use the generator clause. So that means, first of all, the API just only allows valid SQL. So because if you write your SQL statement in a string, you can write whatever you want, right? It doesn't have to be correct. But here you have to have a correct statement because the Juke DSL enforces you to write valid SQL statements. And with the meta model generated here, the competition table, if someone changes the competition table to competitions, for example, because they think that tables must be in plural form, then the code will no longer compile. So you have compile time safety that your code matches the current database. And finally, you have to call fetch. There are various ways to fetch data, we will see that, and it returns a result. The result is just an implementation of a list, because you can also sort your result, and then it returns by default such a competition record. So it uses that record that we defined. That's for fetching. If you want to insert data, we can also write insert statements. So that's more or less the same as you would do with SQL. So you insert into a certain table, define the columns, and set the values. And then we also have the way to return. So with returning result, we can get the ID back because the ID is auto-generated by the database, for example, and we get that back as the result. But that's okay to do that. But often it's much easier, especially if you have a UI where you create this athlete to use directly the record. So that means you also can create a record. The DSL has a method called new record, because if you want to store it, the record has to be attached with the DSL context. So it's similar to the entity manager where you have to call persist to give an object to Hibernate to manage. Here we have the new record, and I can set all the fields, and then call store, and finally that's the way we can store data. Store also means it's a kind of a convenience method like save in Spring Data that you don't have to think about if it's an insert or an update. Juke will figure out if it's an insert or update by itself. And that means I can also update such a record. So I can go here and say, select the athlete with a certain ID. We have fetch that would return a record directly, but there you have to handle null values. So we can also use fetch optional that will return an optional. And then I can, for example, set the year of birth and then store it back, and that this will create a minimal update. So you can also have minimal updates with Hibernate, but you have to define that you want to do that. Usually Hibernate updates all columns, and that's not a good idea, in fact. So maybe it depends how deep you are in the database and how much things you do, but you can, for example, have the idea to write triggers in the database that do something based on a statement, an update, or an insert statement, maybe. And if you have a minimal update, it's much better because you just get the changes that really happened there. So that's one thing. But these records often are not what you want, because what we usually do with Hibernate, we fetch entities, and then we have something like model mapper or map struct and map it to DTOs. These days, these are mostly Java records because these are immutable data structures. And we want to use that here too, because I don't want to update the data, so I don't need this active record. And that means I can use projection. First of all, if I don't do anything, so I just select here the first name, the last name, and the name of the club, for example, then I get back a weird result. So I get the result called record 3 that is typed, so all the elements here are of type string. So I also get type safety in the result, but this is not very handy, because if I want to use that, I have to call get on this record, and also here I can use the column name that is generated in the meta model to get the data out of it. So that's not very handy. It works, but it's not very handy. By the way, I most of the time now use type inference because it becomes much clearer to read, but there's some information missing now. So I have no clue what really the result is, but because we also can nest the result, this typed record can be very long, and it will not fit your screen anymore, and that's why type inference here could be a good thing. But that's still not what we want to do. But let's have a look at the statement further. We see here that we also can have a join to other, and this is exactly the same syntax as you get if you use SQL. But we want to use records, and for that I created the DTO class. It's an applet DTO, the first name, the last name, and the club name. And here you see that we can select that. And here you also see that we have the possibility to use asterisk syntax. You shouldn't do that, by the way. Juke handles that for you because it knows about the database model, but the result or the column order can change. And if you rely on the column order, you get in trouble, and probably you select too much. So in that case, I just need 3 fields, but we have selected everything. And then we have a fetch method that has a lambda as a parameter, and here I can extract the data into an athlete DTO. So that's okay, but too much work, right? So that's just an intermediate step. It feels like a bit like the JPA constructor expression, if you know that, where you can say select from and with the new parameter. But Juke can do better, because Juke can do fetch into, and it then uses or first tries the default constructor, and the record just has one constructor, so it matches very well. And it checks if the arguments are of the correct type, and then it just creates your DTO class. So that's probably the most short one. But something that's a bit annoying here is the join, right? If you know JPA, JPQL, you don't have to write joins if it's a 2-1 relationship. You just have to write joins when it's a too-many relationship, and that's called implicit join, and Chook can do the same. So here I don't do a join, I just write athlete.club, so the tables with 2-1 relationships get like a method where you can do kind of a navigation to the other table and select fields from that table, and that's the shortest one that you can get using this syntax. Very often you want to do sub-selects. So you have a select of a certain table, but you want to have some data from another table, and then you create a sub-select. And you maybe want to have a nested result. And for example, let's have a look at the nested athlete DTO. I want to have a record that has a first name and last name from the athlete. And instead of the club name, I want to have a club DTO inside. So how can I do that? Because this usually is a problem with Spring Data because you cannot load nested structures, right? You can load like flat structure, so you get the product of a join, and you have to, or Hibernate will then extract the data, but you get too much data from the database because there are duplicates inside. And here we can do that. I can select first name, last name, as I did before. But now I call row. Row is called a value constructor. And here I say I just want to have the club name and map that to the DTO. So I can map nested structure as deep as I want. And we will see that in a minute, what happens when I execute that. But here we also can use then just the fetch into, which will transform the result with this mapping inside of the club DTO. And I can execute that. Then we will see what it does. Chook has a debug logging that's very convenient because it logs the statement. Like here, you can see that. Here it only logs one statement because I didn't have any where condition. And Chook, in contrast to other ways to use SQL with Java, Chook is always safe from SQL injection because it always uses prepared statements. And that's why usually Chook, when you have a where condition, logs the statement twice. It logs it first with the exclamation marks or with the question marks as the prepared statement. And the second log will be an inline SQL because usually you also have the problem with Hibernate. You just see these question marks and you don't know what was passed to. And we also see that it returns a sample, so it will never log all the records that you get back from the database because there can be many of them. It usually logs the first 5 records just to, when you're working on the application, if you're developing it, you have a sample of the data and you immediately see if the result is what you like to have. And here we have something nested. And the trick about that is that this row construct is something that also is known by Postgres. So the point is, Chook has many features that are differently implemented by different databases. And you don't have to care about that. You just can write your SQL statement with the Chook DSL, and Chook will figure out how the SQL statement must be generated. That's a good thing, by the way. There is a side project about that, because on the Chook website there is a translator where you can paste in, for example, a DB2 query, and say I want to translate that to an Oracle query. And Druck will do the translation for you because it has to do that anyway, and it knows all the databases. Druck probably supports most of the databases that are out there or that are popular, but Druck has a dual licensing model. So that means if your database is freely available, it's open source like Postgres or MariaDB, then Druck is free for you. And if you use Oracle database or Microsoft SQL database, then there is a fee. The fee is not a lot, and it's also floating. But the point is that for these databases, Druck did a lot of work to get certain features work on the commercial databases. And that's why there is a dual licensing model. Now, this is just a one-to-one relationship. But what about one-to-many? And here it comes to another one. So we have like a series, and in the series has a name, and the series has a list of competitions in our case, right? So if you go to the UI, this is what we see here. That's the series, and if I have a look at it, there are 2 competitions taking part of this series. And I want to load that also in one query. And that's also something that is great. And I would say that's even the superpower of Druck. And this superpower is called multi-set. So as you see before, the row operator somehow is implemented by the database, right? So we see the row in the SQL statement, but we will see what multi-set creates in a minute. But multi-set is something that the SQL expert groups are discussing about because they want to enable nested structures also as results from regular SQL statements. Currently, this is done in a special way because databases can return nested structures already for like, I would say 30 years. I don't remember exactly when, but I would say DB2 implemented XML in the database in the late 90s, Oracle as well. So you could always return XML as data structures. And this is nested, it can return a tree. And in the most recent years, we have JSON that is very popular. So all databases now support JSON. JSON to store, but also JSON to load. And I executed the statement here. And now you can see, when we go down to the query, that we get the name of the series, in that case, the Diamond League, and then we get a multi-set, and the sample here shows something that's similar to JSON, right? It looks like JSON more or less, without the quotes, but it looks a bit like JSON. And if we have a look here at the SQL statement, we see that it really uses JSONB aggregate functionality, JSONB build array functions to create these nested structures. So Druck is cheating a bit on us because it uses JSON functionality from the database, but the point here is it does a minimal select in contrast to Hibernate, because with Hibernate you can do that as well. But Hibernate will fetch, in that case, the series name multiple times for each competition, right? So you have a Cartesian product in that case. And that's how it works. And here we have to do some extra work because we have to convert the result of the multi-set into our competition DTO. But as this is also a record, we can use a reference to the new operator, to the constructor. And finally, we also can select that in the series. And that's exactly what I do if I generate here the competition ranking. So I click here, this generates this PDF with the nested structure. And if we have a look at this query here, it's a bit longer because it involves multiple levels of nesting. By the way, it took me some time to write that query, so it's not that easy to do that. But once you have it, it's easier. The point is, with Druck, you move a bit away from like programming to more a declarative way of doing things, like you do it with streams. So I think before streams, a lot of developers had a hard way to think in declarative things like SQL. But with the invention of streams in Java 8, I think this mindset of we say what we want to have and we don't program what we want to do changed a bit the mindset, and so it's probably easier to write SQL just because we also have streams in Java. And here you see that we have regular select first for the competition, then we have a multi-set with select of the categories, then we have a multi-set with the athlete, and finally we have a multi-set with for the result, and then we have some where condition we can, and that's something unique to Chook. We can order all the nesting. That's not possible with Hibernate, by the way. Hibernate allows you just to order one list. So if you have multiple to many relationships, you can order just one list, or you even can have just one eager fetched list. So it doesn't work because somehow it has to order the result. And here we can order all the nesting. And finally, we fetch that in competition ranking data. And the competition ranking data is just the nested structure of all that, right? So the question now is this faster than what Hibernate is doing? And the answer is, it depends. Because JSON functionality of the database depends on the database. So some are very fast. So the Postgres implementation is not too bad, I would say. The Oracle implementation is faster. So maybe it's faster at all to load the Cartesian product instead of just a minimal result, but it really depends what you're going to do. I mean, I'm creating a ranking list, the user can wait. It takes not long, as you have seen, right? But the user can wait to get the result. If you are very performant critical applications, maybe loading this nested structure with JSON functionality may be slower than loading a table as a result from the database. So that's how it works. And finally, we also can delete data. So we can execute the delete statement, or we could fetch the record and delete that, but this usually doesn't make sense to load data to delete it, because you just want to delete it. You don't need the entity yet. So that's a brief introduction to Chook. Chook can do many more things. As I said, you can generate data access objects that you can get like a repository where you can add then all the queries that you want to write. Sometimes it's even the case that you get the query from someone. So I know a lot of people that are much better in SQL than I am, and they give me a huge SQL statement. And now I have a problem because I have to translate this huge SQL string into Chook DSL, right? And I often don't do that because you can just pass the SQL statement to Chook. This also works. And also there you can use, or you should use, a prepared statement with parameters that you are safe from SQL injection, but that's something that you can do as well. Chook is working on something like that, so that you can take a SQL statement and then give it to Chook, and Chook will generate the DSL for you. So that's often the point behind that. And there are other things. So like you have entity listeners, for example, with the JPA, where you can listen to something like kind of a trigger functionality. That's also part of Chook. So we can write like a listener. We use that a lot to, for example, record the execution time of the queries, for example, or translating queries. So if you have a multi-tenancy application, you usually want to change the schema name, for example, if you execute that. And if you have a look at the SQL statement, you see all the names here are quoted. That means they are case sensitive, but you can configure Chook how it should handle the database, if your database is case sensitive or not, and how you want to have that. That's it. So then the question that still is can I use Chook with JPA or JPA with Chook? And the answer is yes. So JPA has the way that you can execute native queries. And you can use Juke just to build your SQL statement. And then instead of calling fetch, you can call getSQL. And you get back the SQL string also as a prepared statement and pass it as a native query to Hibernate. And then the result of the query will be entities, at least if you select everything that Hibernate needs to construct entities. So you can have both. Or you can have the situation where you say, okay, we have one part of the application is for changing the state. We use Hibernate for that because it fits better our architecture. But for selecting, we just use Juke. And I have both combination in projects where people want to use or prefer to use Hibernate for changing and Juke for reading. So what you never should do, by the way, you shouldn't use entities for reading. So that makes no sense. Hibernate now has a stateless session that you can use for that, but if you don't use a stateless session, if you use the entity manager, your entities will be managed. That means you could change the result of a query, and then you probably have side effects that you don't want to have. And if you want to really choose, then I would say Juke's superpower is really querying. So the nested structure, the multi-set stuff, that's unique to Juke. Spring Data is currently working on something like that, so they can do nesting, but just one level at the moment. They're working on that. Also, the SQL standard is working on that. If you have functions and stored procedures, and yeah, sorry?
Criteria queries, is it powerful, like criteria, right?
Yes.
Could you please mind show some demo on that? You have something to show that?
Juke together with criteria query, you mean? No, criteria query is something unique to JPA. Because criteria query makes sense with the meta model API and is working on the entity model and not on the database level. So that's something different. The criteria, I mean, Juke is pure SQL. So if you know SQL, you can use Juke. Criteria API is one of the worst APIs that ever have been created in the Java space, because as I said, I'm teaching that at the university, right? I have to look up Criteria API every year when I give the course because I have no more idea, because it's not fluent, right? You have the root objects and stuff.
Criteria query, right? You have like a table with a lot of filters, right? Yeah. The UI. So it can be multiple tables.
Yeah.
Yeah. So JPA, it will give you the same performance issue, right? It can filter. It will get every entity.
Yeah.
Back, and we need to.
Yeah, iterate over the result and do that. Yeah. Okay. The point is, the one problem that you usually have in querying is the n+1 select problem. So if you have lazy connections in Hibernate, you access a row or an entity, and then you access, for example, if you translate it with mapstruct to DTOs, and then it will execute a lot of SQL statements. That you never have with Juke because there's no such functionality like lazy loading. So you tell exactly what you want to load, and you have that in one go, and there will never be multiple statements. Only if you iterate over the result and execute your SQL statements like that. Calling functions and stored procedures, that's very superior to Juke. So if you really have a database where you have, or an old or a legacy database, or even a new with stored procedures, then I would always go with Juke, because that makes life so much easier. And in fact, we also use Juke to test stored procedures. So we write test for the stored procedures in Java, in JUnit, and execute it against the database, and that's very, very convenient. On the other hand, we have JPA and Hibernate, and really if you have this entity state transition, if you're kind of into domain-driven design and have this aggregate root, and you want to have that and change from that, and you have business logic on the entity, I would go with JPA. Otherwise, you have to write that in persistence layer, whereas JPA can do that already. And also if you have like a need for cascading insert, update, delete, that orphan removal stuff from Hibernate, then Hibernate is what you should choose. But as I said, you can mix it however you like to. And we also had projects where we started with JPA, we moved then for the queries to Chook, and at some point we completely removed JPA because we were so used to use Chook at the end. So that's it from my side. I'm open to questions.
If you have a database view, you have the same behavior like a table view?
Yeah, the question is, if you have a view with Chook, a view is just like a table, right? A view could even be updatable. So if you have all the non-null columns in the view, you can update a view as well. And so a view is just like another table. The difference is, if Chook sees that the view is not updatable, it will not extend from updatable record, it will just extend from record or readable record, I can't remember exactly. And then you cannot execute store on that. But for reading, a view is completely the same as a table. Yes?
Can you clarify the dual licensing model you're referring to for Oracle and DB2 to others?
Yeah. The question is about the licensing model. You can go to Chook, and the model is very, very simple. So if you use open source databases, then it's free. There's an express version. These prices here are per developer per year, and these are floating. That means if you have a team like with 5 or 6 developers, and not everybody is currently working with database layer, maybe they are on the UI side, and then it mixes, and it's floating. So you probably need like 3 licenses for 5, because not always all people are probably working on the database layer. Yeah. And this is, the professional version is for Oracle and SQL Server, mainly for the big commercial databases. And there's even an enterprise and other licenses. So most of my clients having a license agreement with Chook because they have many developers using Chook. And then the prices are completely different. So I can't tell you about what, because this is then kind of a negotiation how the prices are. But in my opinion, the license fee is worth the money because it's not much, and compared to what you pay for the database, it's just a marginal. It's even sometimes a problem. I don't know if you have the problem as well, but usually you have the problem with big companies that buying something for a lot of money is easier than buying something for just a few bucks. Because of the procurement process in big companies, it's very hard to do that. And that's why there is also like an enterprise version that you can negotiate the price. It's for the big companies. Yes?
Have you heard of anyone using it with PostGIS?
No. To be honest, I don't use PostGIS. But I would say, or don't guess, let's see what we have here. It's not listed, so I don't know if you can use that, or to what extent you can use that, because PostGIS has also functions, so functions could be used in that case, but I can't tell you more about that. Yeah. Yes?
Does it support Oracle custom data types?
Yes. The question is, does it support custom data types? Yes. In our project, we use a lot of them, user-defined types, and also arrays and everything. Yeah. Also enums and stuff like that. So you get everything out of the database as Java objects that you can handle. Yeah. Yeah, that's a very valid point, because if you're writing stored procedures or functions, user-defined types are very, very helpful. And also enums are helpful. And in case of enums, if you use enums with Hibernate, you usually just use the Java enums, and you store the ordinal value or the string value, but that's a problem because you don't have a safe way to check in the database, or you have to write the check constraint, but then you have the definition twice. With Juke, you just have to define the enum in the database, and it will generate the Java enum for you that you can use.
And when it's configuring, generating the classes, can you configure specific objects that you want? Like I don't want to think about from the whole schema, or the database can it just get certain ones?
Yeah, the question is, what does Juke generate? You can define that. If you don't specify anything, it will just take everything it finds and generate it for you. Or you can define I want just that types, or you can have a regex pattern to filter out views, tables, whatever. Yeah. Other questions? Cool.
Calculation on in the definition that you extract when you move the application, let's say the database has changed and you have a older definition there, is there any way to check that, or you need just to regenerate?
The question is if Juke checks anything at startup time. No, it doesn't. So Hibernate has the DDL generation type validate, where you can do that. But Juke relies on the generator mechanism. So that means Juke assumes that you generate the model based on the actual database version, and then it should fit. Yeah, you will. If it doesn't fit, you will get the exceptions when you execute the SQL statement. Yeah, exactly. Yeah. That's a valid point because, and that's also where test containers is very helpful. But test containers not work in all cases. I mean, our ERP system with this huge data model doesn't fit well in a test container. So we have like a reference database that we also manage with Liquibase, but we generate the Juke code against this reference database that is always running. Any other questions? Yes?
How does it prevent corporate upgrades to the record?
Sorry, can you?
Does it prevent the corporate upgrades to the same record?
I can't understand you. I come to you.
There is a chance we could run into corporate upgrades to the same row in the database.
No.
How it does it prevent corporate upgrades to the same row in the database?
The point is that Juke can do many things based on locking. First of all, you can use pessimistic locking. So you can do a update or a select for update, for example, then you lock on the database level. But Juke also have optimistic locking. And you either can specify which column should be the version, for example, like you do with Hibernate. If you don't do that, Juke will use all the columns of the database table for optimistic locking. So it will add all columns to the where condition if you update the row. And it's even better because Juke executes the select for update before doing the optimistic locking check. That means it tries first to, if it's even able to lock the row, and then does the optimistic locking check. Yeah. You can specify that also in the generator, where you define that's a field, which field you want to use, and Juke will add that. Yeah. Cool. Thanks a lot for coming.